First part of this lesson, you don't actually have to do this maths, but you need to be aware of how compound interest is different to simple interest. So if you look on the board, in real life finance and banking, the more complicated form of interest, compound interest is used. Simple interest is rarely used. Like simple interest, the interest rate is a set percentage, but the difference is there's compounding periods where the interest is calculated and you add it on to the principal. So why is it called compounding interest? Because the principal is always increasing, and because the principal is increasing, the interest is always increasing. So you can see that compound interest is just it's a more complicated application of the simple interest formula, but you repeat it over and over again. So we can compare that with this. I have two different calculations. I have simple interest here. It's a $100 investment over 3 years at 5%. The only difference with a compound interest one, it's $100 investment, 3 years, 5%. The only difference is it's compounding yearly. If you can see what the difference is between them that makes them so end up with a different amount at the end, what is it? Can you show me what is the only difference between this maths? Because it all looks friggin' similar, yeah? That is the only difference between simple and compound interest. This interest that you earned at the end of the first year is added on to the principal. And then at the end of that second year, whenever it compounds, because it's compounding yearly, it compounds again and gets added on to the next. There is nothing happening with this $5. It's going into your pocket. Whereas here, it's going on to the amount where you're working out the next 5%. Just be aware of that, okay? But the actual maths that you have to be able to do is this. Compound interest formula. You guys that are on the speedrun timeline, don't worry about this because you're using TVM Solver anyway. I'm teaching this because they need something to do while we're catching up their test, okay? It might be interesting to know, all right? So this is the formula that you'll need on your cheat sheet. The compound interest formula, because it's slightly more complicated and has to deal with compound periods, looks like this. FV equals PV times by, in brackets, 1 plus I divided by K, and everything in the brackets is raised to the power of K times by N. Can you get the formula down, please, for compound interest?
That was an I or a 1, sorry.
That's this one is a 1, yep. But this is a small I.
Yeah.
So FV in this formula stands for the final value of the investment, which is slightly different to simple interest because simple interest, SI is equal to PRT, the simple interest formula tells you the cherry on top. You're working out the interest. There is nothing in this formula that tells you the interest. FV is the principal plus the interest at the end of the arrangement. What does PV stand for? It's the principal. I is the interest rate as a decimal, so just divide the percentage by 100. The little K there stands for the number of compound periods in a year. So if it was compounding yearly, K would be 1. What would K be if it was compounding monthly? Yep. 12. What would it be if it was compounding quarterly? How many quarters are there in a whole? 4. Might as well add because you're in year 12, you're gonna have to handle this. What if it was weekly?
52.
Good. Weekly would be 52. And fortnightly would be?
26.
Good. I've had a year 12 once that went through the whole year and told me there was 24 fortnights, so every fortnightly question was wrong. Lastly, N is the number of years. So this is the formula down here. I'll explain to you, not in book. Please note that this formula I've given you, FV equals PV, etc. It tells you the final value that the investment grows to. If you want to find the interest earned, this is the formula you need. Interest for an investment is equal to FV minus PV plus PMT times N. That is not in your textbook. So a couple of minutes to get down to there, and then I'll do some examples. I'll start putting in what I would put to answer this question. Find the interest earned on a $100 investment, 5% compounding yearly for 3 years. So compounding yearly is important. FV will be, you invested 100 times by 1 plus, what would 5% be as a decimal? Yeah? 0.05 over K. For yearly, what would K be? 1 to the power of K again. 1 times by, how many years was it for? 3. So let me demo how to use the calculator to use bed mass. 0.05, because I have a fraction within the bracket, so I'll deal with that first. Add 1 to it, 1.05. Raise it to the power of 1 times 3 is 3. And then I times the answer by 100. See, by doing that, I haven't lost accuracy. I didn't have to write anything in rounds. So 115.76 to 2 decimal points. $115.76 to 2 DP. That is a use of the compound interest formula. That's pretty much where they stop at year 11. If you did general maths last year, that's all you would have done. Okay? Someone at SACE decided that yearly is where you would stop at year 11. But now we're going to deal with more realistic things. You're going to pretend to buy a house in your assignment. Is this yearly yet? Let's see. $8,800. Placed in an account, 4.8%. Still compounding yearly. What's the contents of the account after 3 years, and find the interest on the investment? So FV is the contents of the account. They put $8,800 in there. 1 plus 4.8% is a decimal. 0.048 over. It's compounding yearly, so what's K going to be? Still 1. K is 1 again, times by, still to the power of 3. So demo the calculator. Although you have a graphics calculator, it's easy to do this. 0.048 divided by 1, add 1 to the power of 3, times that by 8,800. That's telling me there's going to be 10,129. 10,129.00 to 2 decimal points. After 3 years in the account, why did I do this example? Is to demonstrate how to use my interest formula. So interest equals, what did it grow to? 10,129 minus PV, 8,800, plus payments. Does this question indicate the person was paying regularly at all? They just put $8,800 in the account and let it grow. So PMT is going to be nothing times by, and there's N was 1 times by 3, still 3. That's going to be 0 anyway. So it's going to end up being 10,129 minus 8,800. They earned $1,329 in interest by doing that. That's not that unrealistic anymore. The interest rates have risen now since COVID. Although in real life, things compound monthly, not yearly. All right, last example to show the use of the full formula. 12,000 is placed in an account, 3.6 per annum. Compounding monthly is the difference this time. What's the contents of the account after 5 years, and what's the interest on the investment? So demonstrate A, FV equals, they put 12 grand in, times by 1 plus 3.6% as a decimal, 0.036 over K. It's compounding monthly. So how many times? 12 to the power of K, which is 12 again. How many years is it? 5. So, calculator. So this is going to be a nicer chunk. 0.036 divided by 12. Handle the fraction. Add 1 to it. Raise it to the power of 60. Times that by 12,000. 14362.74 to 2 decimal points. After 5 years, B, what's the interest earned on the investment? Interest is going to be what it grew to, minus PV, which was 12,000, plus any payments, which there were none, times by the 60. It's not going to matter anyway because 0 times 60 is going to be 0. So it's going to be $2,362.74 in interest. That's the compound interest formula. Next lesson on Wednesday, it's going to be a big one because you're going to learn TVM solver, where you can pretty much discount and not use the formula ever again. Okay? But I've got some people catching up a test. This will give you something to do between them.